Hey everyone, hope everyone is doing good. So this time on ROOTCON, we'll be presenting our talk on Buzzard, crafting a post-exploitation framework against odds. So probably today everyone has been crafting their post-exploitation framework, but this presentation will be focusing on our challenges and what are the ideas we did implemented on our post-exploitation framework. So let's get started. Next slide, please. Uh, a little bit about ourselves. My name is Subhojit, and I mostly go by the name Elemental X online. I do reverse engineering, and I'm still learning malware analysis, to be honest. And my favorite programming language is Rust, and I still love studying about system internals in my free time. So currently, I'm leading the Axial and InfoSec community, focused on all these domains I just explored. So I'll pass it on to my next teammate, Aravindha, for his quick introduction.
So, hello everyone. My name is Aravindha Hariharan. I'm also known as Tech Wizard in online. So, by day, I'm a final year graduate, and by night, I work as a web app pen tester. I love to play CTFs and hackathons. Currently, I'm part of Axial community as a core nerd.
All right, thank you, Aravinda, for your real quick and sweet introduction. So, I'm sorry, we'll focus on what are the agendas will our slide and our presentation contains. So we'll be explaining what is Buzzard and why did we keep this cool name? Why do we need the need of this post exploitation framework, keeping in mind all the existing and better post exploitation frameworks in the community. And third, key components will just go one by one on the components. Will describe the UI and what did it take to compose that, and exploration of features, all the feature the C2 operator has to and the advantages of using Buzzard. And on fifth, what's Buzz? Yeah, that's a quite a funny term, but it will explain why did we use it. And Buzzard in Docker, how do you load up our C2 framework? That's a kind of feature, honestly. But yeah, as we would like to explain a bit about that, on that we actually allocated a different slide for that. And then will my friend Aravinda will do a quick demo of all the implants and modules, post exploitation modules we made up for Buzzard. Eighth, our 2 cents on detection and Buzzard. And ninth, the future updates which will promise. And 10th, finally we'll end up credits and thanks. All right, Avinda, next slide, please. Thank you very much. So what is Buzzard? Buzzard is open source. Yeah, we definitely will go for open source. Post exploitation framework designed for researchers, students, and enthusiasts. And people who are, nowadays we see a lot of influx of students and enthusiasts, they're trying to build their own post exploitation framework. So we thought, why not give us our part of contribution to the community building this post exploitation framework. Although there are a lot of existing post exploitation frameworks, those are kind of they do have all these extraordinary features, but most of them are paid, keeping us, researchers or students or enthusiasts on the dark corners, so as we cannot explain or we cannot put a lot of R&D into our own if we start to build our own custom exploitation framework from the scratch. And on the other hand, if the UI, we try our best to put in the good things in the UI. So if someone wants to deploy their own implant and the modules using Buzzard, that's another advantage also. And currently, it's an initial release. So Buzzard supports 10 plus post exploitation modules for Linux framework currently, and we're planning for future to go for cross-platform support also. And then the support for Windows machines will be there in the next update. And we would like to clarify that Buzzard is still not capable of operating in mature and covert environment. But yeah, it's a best option if you're trying to, go for developing your own. And we promise that in the next update, we'll definitely make it capable of being, operated in covert and mature environments, and definitely red team engagements. Okay, Aravinda, next slide, please. So
Okay.
anyway, so the next slide contains like why did we build Buzzard? Although there are like many marvelous post exploitation frameworks, but like we would like to name a few like Shadow, Brute Rattle by Pandora Ninja, Post Shitu, Nighthawk by MDSec Labs, and many more. So our main inspiration for building Buzzard comes up from these frameworks actually. So so and other things like we'll definitely learn a thing or two on while building our own post exploration framework, and the techniques or pseudo persistent or persistent techniques or whatever we are packing up in Buzzard on the initial release, those would like to clarify those are not definitely noble, but yeah, definitely like we have implemented ideas to make the tactics quite noble. And we'll definitely go on the next slides. And implants programmed in non-traditional programming languages. So yeah, I think this has been performed, but yeah, we did focus on this thing because we'd like to include a videos and quite a few slides from sacred cash cow tipping. And definitely that's our main reason. And yeah, we'll definitely explain why did we use non-traditional or non-native programming languages for designing our implants and uh, beacons. And yeah, definitely applying NTRA techniques. Every C2 nowadays, like if we build one, has this core component of applying NTRA techniques. So yeah, definitely this has also been one of our goal. So next slide, Aravinda. All right. So now I'll pass it up to my, other teammate, Aravindha Hariharan, to describe the features and, overlook of what and how can you just plug and play around this quick set of framework. Avinda.
Okay. Buzzard is built on a hybrid architecture. That means it comprises of multiple components to have a smooth running of process. So they cannot come back and break the C2 server. And we follow CRUD operations through front end is built upon top of Node.js and HTML, Bootstrap, all those stuff. We have a middleware with API, which is made up of Python, and the Node.js will be interacting with Python to create, delete, read, and update all the tasks. So let me switch back to the interface and show you. So this is how the interface, the Node.js and HTML looks like. You have a classic login page as well, but once you log in, you will have this kind of dashboard with sidebar as well. So you'll have options to create, view, edit, and do stuff. And you will have the list of tasks that are created by you. And this is a data table which will be sorted. You can search among the task that you need. You can search by the IP address. You can go with the timestamp. And we have a status indicator also. So if that particular task is not yet started or not scheduled, then we have three stages. So not yet started or in progress, or if that particular task is completed, then it will be marked as completed. So you can switch back between them and filter it. And then we have a one liner over here, so you can just copy it immediately and paste it into the target machine to get started. Let me go back to the slides and show you that as well. So this is the architecture which we were referring to. So this is wrapped around the Docker. So we have client and a client as web interface and command line interface as well. So that will be talking to the reverse proxy that we set up in the server side. So that will redirect to the respective services like the REST API, the Node.js one, and then MongoDB. We have the WebSocket to get a real-time update when you create a task or when you edit or when you get an scheduled notification, you will be notified through WebSockets. And then we have beacons and implants, which will be served through the REST API. And this all goes, and we have the implant be planted into the compromised server or the system where we refer it as an victim machine. So this will be implanted into the victim machine, and you can access through the server which we have set it up with the public IP of the attacker machine. So you might have a question how we will be loading this implant into the target machine. So we have made two different implants. One is for the Windows version, and another is for Linux. So this is how the one-liner will look like. You just need to copy and paste it into the terminal. And what this will do is it will create the init script. So when the victim restarts or powers off the computer and turns back in tomorrow, it will be automatically starting up, and we will have a persistent connection. If he is going to find the script which we planted, it will be renamed or rerun in a different name. So it is not being caught by the victim. So this is how the one-liner look, and you can just copy it from here and you can paste it into the victim machine. Let me show you how to do that. You can just click it and it will copy it to the clipboard. You just need to go into the victim machine and then you need to paste it. So this will pull some required files from the machine, and it will create a init.py with the name Buzzard. So this has been set, and you can see the where implant has been put into safe side. Then we will switch back to the slides again. So now coming to the first feature, we have monitoring targets, where Buzzard gives you a feature of looking into your targets in a real time. So if a target is on online, then you have a monitoring feature over here, which is called as profile, and then we have targets as well. So I clicked on the wrong one. Just a minute. Okay. Over here you can see different targets that are being given. So it just wait for 15 seconds whether the target comes up online or not. If the target does not come, it reports it as an offline. And if that particular target is up, and then you can see this particular green signal, you can see the notification as well. So when the target is up and running, you can check whether the target is online or offline. So there's an issue, that's why it's showing like this. We will go back to the slides. Then creating tasks in Buzzards are quite simple and easy. You just need to click on the create task button in the dashboard, or if you prefer CLI version, the command line interface, then you can download them from the dashboard, and then you can create using the commands which we will showcase. And then you just need to type in few information about the victim, like the task name, the IP address, and it will just create it. So let me show you how to create it. Over here, you see the dashboard, and we have the new task or the create task button over on the right side. And once you click, it should redirect to a new page of create task. And then you just need to type in something, the name, which should be unique, and then the target IP. And we support two different operating system, Windows and Linux. So next we have like the modes of operating the beacons. So that's the next option. So we have two different modes as long haul and short haul. What does that mean? Is long haul is the beacons that will be scheduled later in part. So it will be slow and still, but it will be able to bypass the techniques using the traditional method in AVs and ERD, and then it will be stealth, and it will run 15 minutes once, so it does not being caught by some other packet tracing tool or something like that. We have short howl also, which will make lot of noise in the machine, pretend to be caught by someone when they look back into the beacons. So we have two different long haul and short haul. Then we have like give options to the operator, the attacker, to choose various programming language that we have made. So like if the attacker likes to give a payload on Python or in C programming or in Rust, then he can choose that particular language. And currently we support three languages: the Bash, Python, and Rust. So that will be capable to make, that will create the beacons, and it will be deployed into the victim PC. So I'll just show you that thing. So we have languages based on the operating system, it differs. So if it is going to be Windows, then we have the Python PowerShell. If it is going to be the Linux one, then we have Python, Bash, and Rust. So on clicking up the particular language, you have called bus. So let's look what is bus then. Bus is nothing but the name of the beacons that we kept, just because it is going to be fancy. We kept it. So bus is the beacons that we refer, and these are the modules that will be used to gather information in different PC. So we have different beacons that we built, and then you can choose among them, or else we have the custom beacon script as well. So you can build your own beacon, and then you can give a name to that bus, and then you can, we have a code editor over here, so you can type in all the codes into this, and you can create a task. So on click on submitting or creating a new task, it will be on your dashboard. And once the payload or the implant which we planted into the victim machine, once the program gets to know about the new task, it will just schedule the task in the time. And long hold and short hold difference will be running in asynchronous process. So once these are scheduled, you will be getting a notification that this particular process is scheduled. So, and once the task is completed, you will get a notification that that particular task is completed. So this is how it works. Then let me show all the beacons and those stuff. So let's go back into the dashboard. And let's create something new. So I'll just delete those things so that you can see it. You can see those notifications once the task is deleted. So let me create a new task. Let me have it as a sys information. I just need to grab the system information from the attacker PC. For that, I just need to grab the public IP of this machine. Assume this as the victim PC. So this is the public IP of this machine. And once I get it, I can paste in the target IP. Since this is a Linux machine, I'm going with the Linux one. I just need to grab the output as soon as possible. So I'm just grabbing the short hold, and let me go with Python one, and we'll select the beacon that says sysinfo. So once I click on that, everything looks good. So let me submit it. So once you submit it, you should see a create task, new task. Let me replant the implant. You can see there is no much of the output, because every task that is performed on the victim machine is like a quiet operation which does not make any noise, and it will not be detected in the AVs or the antivirus that is present in the machine. And let's create a couple more, and let's check. Let's grab the screenshot of that particular machine. Let's have it as long haul, and then we can grab the screenshot module, which will grab which will take a screenshot and upload it to the server. And then we have keyloggers. So let's name it as keyloggers, the IP without longer, you can see the notifications so that that particular process is completed, and we will look into the output in a minute. So I will schedule this one as well. So you can see the system information task that I set it right now has been completed. Uh, Once you click this particular button, you will see the task details. So you have the task information about the task name, target IP, language, and what beacon we use, the Linux, and whether it is scheduled or completed, at what time it has been completed. And then here we have the output of that particular beacon. So we have the system information, the memory, disk, and then types of partitions we have, and then the network information, all those stuff. So let's go back. So based on the long haul or short haul, it will act accordingly. Since I have made a keylogger, let me type something. So it gets captured and it will report back to the server. So let me schedule. You can see that it was in progress, and then we can get the process list of the Linux beacon. Let's have it as process list. The IP. It runs in an asynchronous manner. So even if this particular is running, it does not stop from running this particular task. But since we have made it as a long haul, it will run only after 5 minutes. So we just need to wait for some time. Meanwhile, we will schedule other tasks. So you can see this, it is in a long haul. So we will schedule other tasks and we will get the output. Yeah, version screenshot. We have the port scan one and then file scan. So I just need to rerun the process. There's something went wrong. I will just show you the last one, which is the profile feature where you will have the username, mail ID, the login information, and then we have the API key, which will be used by the attacker to get access through the CLI version. And then we have the download feature as well. So this will get you a CLI.py file into the, and this should have your all the features and then the API keys, and you can interact with the Buzzard through that. If you don't like the web interface, let me showcase that as well, and then we will move on. So sorry. And it takes few other arguments. So you can create tasks, you can check the result of that particular task, you can list the task. Then when we create a task, we just need to name the task and give a target IP, and then what type of beacon we use and whether it is short haul or a long haul. And you can list the task as well. So and it will go and look up for the tasks that are assigned by this particular user, and you'll have all the information. And you can see the screen grabber, the screenshot beacon has been completed, and you can see the screenshot that has been grabbed from the beacon that we implanted, and you can see over here. And then I guess that let me hand over to the elemental and you will take from the.
All right, Aravindha, thank you very much for your real quick demo. So I'm sorry, I'll just do a quick overrun on all the things Arvind that discussed. So the first thing before getting to this slide, the first thing is like all the modules we have are and should be propagated via the short howl, because I think it's not persistent enough, and it creates a lot of noise in the the client machine, to be honest. So currently Buzzard is not capable of handling anti-detection techniques. So I mean, I can just get to the detection slide if you don't mind. All right, thank you very much. So as I discussed that Buzzard is not capable in this first release to bypass custom EDRs and AVs, but yeah, definitely on the next release we'll pack it up with stealth and persistent beacons, and whoever the operator will be using Buzzard should and must go for long haul moment, because a long haul mode, sorry, so that just you can deploy stealth and persistent based beacons. All right, Aravind, the next slide, please. Yeah, future updates. So once again, just doing a quick overrun. All the beacons we have right now are made of Python, um, Bash, and Rust. So basically, we are planning to develop more full-fledged modules or beacons, in the future updates, and cross-platform support. Now, although our, custom beacons or modules, whatever you call it, support Windows based operations, but yeah, definitely we think as developers, we think it's not full-fledgedly, supporting. So it's in a semi-stable mode, and as the main goal of modern day C2 should be to uh, play around the custom AVs and EDRs, and help the detection engineers to have a look on how actually attackers can evade their the daily job. So making it a sort of uh, persistent, and then modules and implant in Rust, Go, and Neem. So you might be curious, like, why do you include Neem, Go, and Rust? All this you can go for native beacons. So based on this Rust, Go, and Neem, I guess I mean all these languages are backed up by LLVM, which is definitely is a good candidate for AV bypass, to be honest. So that's why we will be going for Rust, Go, and Neem, and more implants in future. And definitely, as as programmers, we always prefer dark over white, right? So all these themes and all. So definitely, all this on the next update will be bringing a dark theme, which also eyes also relaxes it, and definitely additional modules in Python, and more stealth and persistent modules in Python on the next update. I mean, the next slide, please. I'm sorry. Our 2 cents as us authors or developers. Honestly, it was a bit tedious work for us, because without having custom or prior red team experience and full-time research, as being students and learners. But yeah, definitely, as we told, we aim it for making it that still and persist in our future updates. And definitely, right now the release of Buzzard is in beta version, and yeah, you can play around, plug and play around with it. As my friend Aravinda, this demonstrated, that you can add your own custom beacons also. So that's a quite a good feature. You can just play around and test over your skills around your this custom AVs and ADRs. So that's a good skill. And definitely we do have a like decent UI for making the operator's job quite easy. And yeah, definitely we would like to appreciate the red team community, and definitely post exploitation feature developers for inspiring us to make Buzzard whatever it is. And then yeah, then this project will be completely open source, and we're planning to maintain it for next 1.5 years, deploying beacons programmed in all those languages which are a good candidate for bypassing AVs and EDRs, that it helps both the red team and the detection engineering community. With the next slide, please. All right, time for a quick credit and thanks session. Definitely would like to include Batsek in our word, because this guy helped a lot, because and as with his all his knowledge with he had, and definitely allocating us time. Ninja Paranoid for helping us whenever we raised him, and yeah, definitely Brute Rattle actually inspired us to build, a basic custom post exploitation framework like Buzzard. RKVL for helping us out whenever we raised him, and support for his Go beacons. Shogun Lab actually released a quite book. You must check it out. Building a post exploration framework from scratch, and that book has actually helped us a lot to design Buzzard. If that book hadn't been released, probably Buzzard would not exist, honestly. So thanks a lot, Shogun Lab, and awesome red teaming community for their R&D against EDRs and AVs, and definitely we would like to include detection engineers in our words, because they're the one who provide us feedback to improve ourselves. So without detection engineering community, probably more we would not be able to develop C2. So a huge hats off to defenders and the detection engineering community. And yeah, definitely sacred cash cow tipping workshops for that unique idea, to include beacons and implants for the with other this languages, various programming languages, and Whale for providing us a decent amount of overview and improvements, and Trickster Zero because for his offensive Rust repo we have included some Rust beacons. So definitely a huge thanks goes to him. All right, Arvind, the next slide, please. All right, that's a quick wrap of our post exploitation module, or what a framework you call it. And yeah, definitely all the promises of this custom beacons and all these things will definitely keep it engaging. So all right, so that's a wrap. And if you feel free to ask us a question in our Discord chat, and definitely if you got suggestions, yeah, definitely we'll love to have your suggestions and positive criticism to improve ourselves, definitely. So if you reach us out as our official Discord server, the slides will also be available. So all right, and thank you very much for hanging us out and dedicating your important time to hear us out about our challenges on developing a post exploitation framework against odds. All right, that's a quick wrap, and hack the planet. Thank you very much. Thanks, Aravinda.